And welcome to part 15, following the restoration of our 2-foot Fowler narrow gauge locomotive, Tully Sugar Mills number 5. This episode's going to be on the coupling rods and connecting rods and the eccentric rod. This is the original works drawings, which again we were lucky to get. You can see it's marked up 16337 to 16341, which is of course our locomotive from that little batch of 5. Here's the coupling rods, connecting rods and a bit of the valve gear as it was when we found the locomotive. And this is the bearings having been pressed out and in the process of being pressed out. You saw this in an earlier film, but I thought it was worth a little recap just to show you pressing out the original bearings where we had them. In this case, the coupling rods that couple the front set of driving wheels to the rear set of driving wheels. It's only a fairly light duty press this. It goes up to 12 tons and we probably used no more than 5 or 6 to press these bushes out. Now the rods themselves were then shot blasted, primed. We ground away with the angle grinder all the little burrs and then finished them off with the red primer here. So we got them neat and clean so we could handle them in the workshop properly, and masked off the internal bores having pressed out the bushes. So looking down on the plan view to get a good idea of where these rods fit, the coupling rods are the first ones that you can see that connect the front set of driving wheels to the rear set of driving wheels on the fly cranks. And that's the connecting rod from the big end to the little end where the crosshead and piston rod is for the actual cylinder. Now closer in on the actual crank pin itself, and you can see the detail of the bronze bushes that go in there from the rod to the crank pin. Now the original bushes had obviously already worn and then been bushed out. You can see it's been bored out and a smaller diameter tube has been pressed in so that it could take up for the increasing wear that had been ongoing at Tully Sugar Mills. And then furthermore, we took the original fly cranks with the crank pins and we machined them down again to get a nice fresh clean surface, which was obviously then undersized from the original as well. So at that point we've effectively got the worst of both worlds. We've got an undersized crank pin and we've got an oversized hole in the bore of the bronze which has already been rebushed. So we took the decision to make new bushes in this case. Now you can see here the dial gauge checking for how nice and smooth and round the surface of the hole where we've pressed the original bush out. The dial gauge is twitching a little bit, which shows that although it's round, it's not a smooth round surface. So again, we took the decision just to take a very thin skim off there, just a few thou, just to try and make sure we got a perfectly round surface to go in. As we were making new bronzes anyway, we could then make them ever so slightly bigger as well to fit perfectly. Just a good way of starting with an extremely accurate centre. The distance between the centres of the bushes on each end of the rod is even more critical. That has to match absolutely perfectly the centres of the axles, because the rods being set at 90 degrees to each other would go tight if they had any anomaly in that length, so it's crucial to get them accurate at this stage. This is the raw lump of new bronze that we're using to machine the bushes from, and here's a little clip of machining those bushes. This is machining the outer size and in a second boring the internal. These lumps of bronze, that one alone that you just saw was £80 plus VAT, so it's really quite expensive to buy the raw metal before you get into any of the actual machining processes these days. So the next process is quite interesting, and I'm glad we can show it to you. You'll see that this bush, when it's been made, gets popped in the freezer. The freezer takes the temperature down to -5, something like that. Not massively cold, but enough to shrink the actual size of that bush. So the external diameter reduces. And this is Neil rushing through to the larger press that we've got that goes up to about 30 tons. He's lining it up with the freshly bored bore that we have in the end of the rod. We've got the old bush on top just to use as a press effectively, and a plate to spread the load evenly, and then Neil just takes a couple of seconds to level it all up and get it exactly where he wants with the press itself as close to the centre as he can of the new bush, and then we're against the clock really to get it pressed in. So Dave's pumping the handle down, getting the press on, and it'll press that cold, as you can see with the frost on the outside, brand new bronze bush into the fresh bore. Now the external diameter of that new bronze bush is actually 5 thou of an inch larger than the hole it's been pushed into. So it'd be really difficult to do that if it was at room temperature, but when it's frozen like that, it just reduces it by 3 or 4 thou, so it's only now currently 1 or 2 thou oversized, so it's easier to push in. And as it warms up, you'll see that the pressing gets harder and it starts to make more of a loud noise as it's pushing that 3 thou and that 4 thou into the hole. So that's the way that we've got them in there. Now, interestingly enough, the internal bore where the crank pin goes through has to have, according to the Locomotive Manufacturers Association handbook, it should have between 12 and 15 thou clearance on the crank pin and the internal bore. Now, of course, we could machine it to that, but as soon as you then press it in with a 5 thou tolerance on the outside, that shrinks that down. So what we actually had to do was we bored the internal bore of the bush to allow an 18 thousandth of an inch oversize hole, so that by the time it's been squashed into the end of the rod like that, you've pressed that 18 thou down to about 12 to 15 thou. So that's how we've achieved that accuracy at that point. Pressing in the other end, you can see that's nearly all the way down until it goes solid. Neil will then flip it over just so that he can check, as he did on the other end, that it had gone in completely square and true, and that it had all gone down to the right area it needs to be. You'll see when he does flip it over that there's a radius, a smooth radius in the other end of the bush. And that's because that goes up against the root of the pin itself, which you perhaps remember from the view earlier is also radiused. Generally speaking, a square straight edge on a pin or anything mechanical is a fracture weak point, a point where all the stresses can get localized on, so it's much better to have a smooth radius at any potential angle than any other shape. Back to the drawings, you can see in the end of the rods, you probably saw it earlier, there's a threaded hole in the bottom. This is for this locating bolt, which is threaded with a little location lug on the end. We salvaged a couple of original bolts from the locomotive and turned them down, and what happens is they are designed to go in those holes, and that little lug on the end just pushes into the bronze, so it stops the bronze from rotating. You can see it goes right through and it just sticks into a hole in the bottom of the bronze. Now, we've pressed them in, they've got a 5 thou grip there, so they probably wouldn't have moved anyway. But there's actually an oil hole in the top, so we couldn't risk them spinning to allow that to slip. The oil hole goes into oil pathways, which are on the drawing here. Now, they're quite complicated on the drawings, but we found that looking at the original bushes, seen here, that Tully Sugar Mills had just ground things out with an angle grinder to get the oil into the right place. And we felt that was okay, although we'd like to do a neater job. So we made up a little template, and this is Neil manually grinding out an X at the top of the bush from the oil hole, so that the oil will feed nicely in and around the top part of the bush and then flow round to the bottom. That's another reason for the 12 to 15 thou tolerance that is recommended to have in there between the crank pin and the bush. Everything gets hot, everything expands as it's in use, and you need a pathway for the oil to flow as well, otherwise it would just wear. And of course the oil supply to the bearings comes from these little oil pots, which you can see on the top of each end of the rod on the original works photo there from 1924. We had one, this was it. The rest, where they were there, was a Tully modification like this, which is just a steel tube fabrication. We cleaned the original one up, as you can see, but we'd only had the one, so we decided to make a brand new batch of them to the original works drawings so that they'd all be matching on the loco. This is those drawings, and you can see there's a brass cone at the top. When you push down on the brass cone, it compresses the spring, and that opens up a little gap for the oil to come down the side into the reservoir. And then there is a tube up the centre of that where there would be a wick in dangling down into the reservoir that would wick up the oil and send it down into the actual bearing itself. Now, luckily, Reg Thomas from the Australian Narrow Gauge Railway Museum Society, the Woodford Railway over in Queensland, already had the pattern. So he very kindly cast us a bunch of new castings, which we had shipped over from Queensland, and then we machined them all up here, which you can see in the process of being done. Ian in our workshop bored them out, made the brass tube up the bottom, and then that brass tube will be inserted and silver soldered into place. That creates the tube that the wick can sit in, as we looked at on the drawing. Once the basic machining had been done to the base and the caps, as you can see here, we threw them into our vibro polisher, which vibrates and bashes ceramic beads into them to polish it all up and take some of the edges off and take that machining finish down to a more polished finish. It's a little bit quicker than doing it manually. We then did it manually as well afterwards, but that certainly takes the edges off and makes them look a little more aged. Now in the top of the rod, there's 2 holes for studs. So we did have a couple of original studs, but they were again pretty gnarled. So we made new ones for each end, and then the studs and the nuts and the lubricators were fitted. And you can see here the workings exactly as you've just seen on the drawings. So I'm unscrewing the lid, and you can see inside there's the little cone sitting on the top of the spring, which goes round the tube, which will ultimately have a little wick in there and oil. So again, grateful to Reg on that one. It definitely got us a step forward and we didn't have to make the pattern. And really, I think you'll agree, rods are starting to look really nice now. Next little bit here is the eccentric rod and the return crank. So this is the rod, and at this end is the return crank. Now the return crank had similar problems to the main crank pins and fly cranks that we had. It was a bit rusty, it was a bit gnarled, and it really needed new surfaces. Now the end of the pin here is actually just for a collar to locate that retains the rod with a cross pin through it. So we didn't do anything there other than just take the lightest skim off the surface again, just to make sure everything was centered. We skimmed up the face next, and then our original plan was just to go for the main crank pin to just take a lightest skim off it, because it measured with the dial gauge reasonably good, even if it just had a little bit of a pitted surface. But when we started to actually machine it, we found that the surface was rock hard. It had been case hardened, and the fly cutter just kept working its way out, so we couldn't machine it square. So we took the decision to cut underneath that hardened surface, take a much bigger cut, thus making the pin undersized, so that we could then press on to inner ball bearing, roller bearing shells, which again you've seen us use before, because it's a really good way of getting a very hard surface that's accurate on the pin. This is just some more lubricators. These are the little ones, slightly smaller design with no big reservoir underneath them. That was the only one we had left that was battered and gnarled, so we made brand new ones so they were all the same. This time there's no mechanism inside it, just a little reservoir inside the end of the rod to hold the oil, and that was that. As always, thanks ever so much for watching. There will be another one along hopefully soon. I'm sorry we're not quicker at making them, but hopefully not long before the next now. Thanks again.